question is whether disconnect for a 120-volt electric pilot light on a gas heater needs to meet the 3-foot disconnect rule. The answer is no, it does not. The National Electrical Code, or NEC, outlines specific requirements for disconnects based on the type of equipment and its voltage. In general, a disconnect switch is required for equipment that needs to be serviced or maintained to energize the circuit for safety purposes. The 3-foot rule you are referring to likely pertains to the working clearance around electrical equipment. However, pilot lights, particularly those operating at 120 volts on gas heaters, are not typically considered equipment that requires a dedicated disconnect within 3 feet for standard servicing. Disconnect requirements are often tied to larger heating appliances or control systems, not the pilot light itself. The NEC addresses disconnects for various types of equipment in Article 422, covering appliances, and Article 430, dealing with motors, motor circuits, and controllers. The specific requirements for heating equipment disconnects can be found within these articles. To understand why a separate disconnect is not mandated for the pilot light, it is important to differentiate between the main heating unit and the pilot light. The main unit, which could be a gas furnace or water heater, does require a disconnect that meets specific requirements. This disconnect should be readily accessible and located within sight of the equipment, or be capable of being locked in the open position to ensure the equipment is de-energized during maintenance. The pilot light, on the other hand, is a small component used to ignite the main burner. Its power consumption is relatively lower, and it does not pose the same level of electrical hazard as the main heating unit. The main disconnect for the heating unit would typically de-energize the entire appliance, including the pilot light circuit. Therefore, an additional disconnect solely for the pilot light is not usually required by code. It is also crucial to consider the specific listing and labeling of the gas heater. The manufacturer's instructions often dictate the required electrical connections and disconnect requirements. These instructions are considered part of the equipment's listing and must be followed. If the manufacturer specifies a disconnect for the pilot light circuit, then a requirement must be adhered to. However, in most cases, such a requirement is not present. Several factors determine the need for a disconnect, including voltage level, current draw, and the type of equipment. For example, equipment operating at higher voltages, such as 208 volts, 240 volts, 277 volts, or 480 volts, generally requires a disconnect due to the increased risk of electrical shock. Similarly, equipment with a high current draw necessitates a disconnect to safely interrupt the circuit in case of a fault. In the case of a 120-volt pilot light with a very low current draw, the risk is considerably lower than that of the main heating unit. Consider a typical residential gas furnace. It usually has a 120-volt power supply that controls the blow motor, gas valve, and ignition system, including the pilot light. The disconnect for this furnace is typically located near the unit, allowing service personnel to easily de-energize the entire system before performing any maintenance. This single disconnect serves the purpose of de-energizing all components, including the pilot light. It is important to consult the NEC and local electrical codes to ensure compliance with all applicable regulations. Local codes may have additional requirements beyond those specified in the NEC. It is also advisable to consult with a qualified electrician to ensure that all electrical work is performed safely and in accordance with code. Now, let's talk about some common scenarios. Firstly, consider a gas water heater. It usually has a 120-volt power supply to control the gas valve and electronic ignition. The disconnect is typically located near the water heater, allowing service personnel to easily de-energize the entire system before performing any maintenance. Secondly, consider a gas fireplace. Some gas fireplaces have a 120-volt power supply to control the ignition system and blower fan. The disconnect is typically located near the fireplace, allowing service personnel to easily de-energize the entire system before performing any maintenance. The exception to the rule could arise if the pilot light circuit is fed from a separate branch circuit. In such a case, a disconnect would be required for that specific circuit. However, this is not a common configuration for residential gas heaters. The important thing to remember is to consult the equipment's listing and labeling, the NEC, and local electrical codes to ensure compliance with all applicable regulations. Also, it is important to consult with a qualified electrician to ensure that all electrical work is performed safely and in accordance with code. If you are unsure about the requirements for a specific installation, it is always best to err on the side of caution and install a disconnect. This will ensure the safety of service personnel and prevent potential electrical hazards. Remember, electrical codes are designed to protect people and property from electrical hazards. By following these codes, you can ensure that your electrical installations are safe and reliable. Some of the important factors to consider when determining the need for a disconnect are voltage, current, equipment type, and local codes. By carefully considering these factors, you can make an informed decision about whether or not a disconnect is required. It is also important to note that the NEC is updated every 3 years, so it is essential to stay up to date with the latest requirements. The NEC is a comprehensive document that covers a wide range of electrical topics, so it is a valuable resource for anyone involved in electrical work. Another point is to understand the difference between a disconnect and a circuit breaker. A disconnect is a switch that is used to de-energize a circuit, while a circuit breaker is a device that is used to protect a circuit from overcurrent. Both disconnects and circuit breakers are important safety devices, but they serve different purposes. A disconnect is used to isolate a circuit for maintenance or repair, while a circuit breaker is used to prevent damage to equipment and wiring. When working with electricity, it is always important to follow safe work practices. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and using insulated tools. It is also important to de-energize the circuit before working on it, and to verify that the circuit is de-energized before touching any wires. When in doubt, it is always best to consult with a qualified electrician. Electrical work can be dangerous, and it is important to take the necessary precautions to protect yourself from electrical hazards. Now let's delve into specific sections of the NEC that might be relevant, even though a separate disconnect for a pilot light is generally not required. Article 422.31 discusses the disconnect means for appliances. While a pilot light might be considered part of the appliance, the main appliance disconnect typically covers the entire unit, including the pilot light. Article 430 covers motors and motor circuits. This article is less relevant to pilot lights unless the gas heater uses a motor, such as a blower motor. In that case, the motor disconnect requirements would apply to the motor circuit, but not necessarily to the pilot light circuit. Article 440 addresses air conditioning and refrigeration equipment. This article is also less relevant to gas heaters, but it provides valuable information about disconnect requirements for other types of equipment. Article 600 pertains to electric signs and outline lighting. While a pilot light is not an electric sign, this article provides insights into the disconnect requirements for low-voltage lighting systems. Remember that the goal of a disconnect is to provide a means of safely de-energizing the equipment for maintenance and repair. The disconnect should be readily accessible and clearly labeled. It should also be capable of being locked in the open position to prevent accidental re-energization. Consider the implications of not having a disconnect. Without a disconnect, service personnel would have to rely on the circuit breaker to de-energize the equipment. This can be problematic because the circuit breaker might be located far away from the equipment, and there is no guarantee that someone will not accidentally re-energize the circuit while work is being performed. A disconnect provides a local and reliable means of de-energizing the equipment, which enhances safety. In addition to the NEC, local electrical codes may have additional requirements. It is important to check with your local building department to ensure that you are in compliance with all applicable regulations. Local codes may be more stringent than the NEC, and they may address specific issues that are not covered in the NEC. For example, some local codes may require a disconnect for all electrical equipment, regardless of voltage or current. Others may have specific requirements for disconnects in certain types of buildings, such as hospitals or schools. It's also useful to consider the concept of arc flash hazard. Arc flash is a dangerous electrical phenomenon that can occur when there is a fault in an electrical circuit. Arc flash can cause severe burns, blindness, and even death. Disconnects can help to reduce the risk of arc flash by providing a means of quickly de-energizing the circuit in the event of a fault. However, disconnects are not a foolproof solution, and it is important to take other precautions to protect yourself from arc flash hazards. These precautions include wearing appropriate personal protective equipment and using insulated tools. Finally, keep in mind that electrical codes are constantly evolving. The NEC is updated every 3 years, and local codes are updated on a regular basis. It is important to stay up to date with the latest requirements to ensure that your electrical installations are safe and compliant. You can stay informed about code changes by attending industry seminars, reading trade publications, and subscribing to online resources. In summary, while a dedicated disconnect switch for a 120-volt electric pilot light on a gas heater is generally not required, the main disconnect for the heating unit serves to de-energize the entire system, including the pilot light. Adherence to the manufacturer's instructions, the NEC, and local electrical codes is crucial for ensuring safety and compliance.